All right, so we're going to continue with chapter 17. And what I would like to do is make sure that make sure we know those 7 rules, those 7 steps. 7 steps for a hypothesis test. Okay? This is going to be the outline we're going to follow for the rest of the chapters. Okay? So, who remembers what that is? What's step number 1? List all board numbers. List all board numbers. If I were to give you a quiz on this, you think you could give all 7 steps?
No.
No? By Friday, could you? Okay. All right, step number 2.
Is it quantitative or categorical?
Is it quantitative or categorical? Step number 3.
Find null/alternative hypothesis.
Find the null, the alternative hypothesis. Step number 4.
Pick correct test.
Pick correct test. Now, here's what I would like to do. Okay, I kind of gave you a little bit, I want to give you a little bit more information on step number 4, okay? Because step number 4 is going to be the hardest step, okay? So, if it's quantitative, then it could be one of 2 tests, okay? If it's a 1 sample mean and sigma is known, and so this is what I want you to do. Some people actually memorize these 7 steps, especially step number 4. This is going to make your life easier. You don't have to, but it's probably a good idea, okay? 1 sample mean is going to be x bar, z equals x bar minus mu over sigma over the square root of that. Okay? Then we're going to do a 1 sample mean sigma unknown. Okay? This is going to be a t-test, which is also x bar minus mu over s over the square root of that. Okay? So you see these equations are very similar. We haven't talked about the t-test, and we're not going to talk about it yet. Okay? But just know that's coming down the pipe.
What does S stand for?
What does S stand for?
Is that the standard deviation of the sample?
Standard deviation of the sample.
Okay.
Okay? All right, then we'll do part B, which is if categorical. There might be another test that I throw in here. I'm going to show you these main ones. If it's categorical, then you also have 2 choices. Okay, it's going to be a 1 sample proportion. That's also going to be a z-test, but the formula is going to be different. Okay? The formula is going to be p hat minus p over the square root of p times q divided by n. Okay? And finally, we're going to do an independence test. Independence. Okay? That's going to be a categorical test. That one's going to be a chi-squared test of independence. That looks like a script X. It's the Greek letter chi. And it's going to be the sum of the observed minus the expected squared all over the expected. Okay? We'll probably learn that right before Thanksgiving. Okay? All right. Now, so what I will say here, Okay, I'm just going to emphasize this. How do you pick between Z and T? Because this will be the one that you guys, well, this will be one of the ones you guys are going to show.
If you know or you don't know your sigma.
If you know the sigma versus you don't know the sigma. You're always going to know your S because you collected the data. Okay? The question is, do you know the sigma? If you know the sigma, it's a Z. If you don't know the sigma, it's a T. Okay? All right. Okay, so those are the first 4 steps. Step number 5 is what again?
Find the p-value.
Find the p-value. And what are the 2 ways? I think this is what Abby asked me at the beginning of the class. What are the 2 ways to find the p-value? I'm going to ask you. Been doing them all semester. Some better than others. Karen knows. Can't hear you.
The z-test, right?
Well, so if I give you a z-score, how do you find the p-value? You're either going to use the chart, or you're going to use the Excel commands, right? Okay, so we're gonna talk about those. Okay. Now, the one thing that I want to say here is maybe I'll add a third thing. Okay. If it's a two-tailed test, if it's a two-tailed test, you need to double the p-value. How do you know if it's a two-tailed test? Annie, how do you know?
I don't know.
If it's a two-tailed,
How do you know if it's a two-tailed test?
if it has everything not equal, if that's equal sign.
Yeah, it's from the null and the alternative hypothesis, right? I said Annie, but Abby answered.
I still
Okay.
don't know.
It was good thing Abby stepped up. Okay, does that make sense? So, you know, it's two-tailed based on your alternative hypothesis. Okay, so that's why so these steps kind of build on each other. Okay, so you use these for later. Step number 6 is what?
Decide to reject or not reject.
Okay, reject or do not reject. Okay, now, some of you, I'm going to refer to this as the A word. Some of you, we are to never accept. Okay, so we're going to call the A, I'm going to refer to accept as the A word. It's now a swear word in our class. Okay, we'll never say that. Some of you are going to be very tempted because you think the opposite of reject is to accept, right? No, the opposite is to not reject. Okay? Now, do you remember when we talked on this Monday, remember the person got 5 tails in a row? You were going to call them a cheater, right? But can you get 5 tails in a row flipping a coin? Just by chance? Yeah, it's unusual. It happens about 3 times out of 100. So that's why we reject or we do not reject. We never accept the idea, okay? If you and I are betting, you would never accept, or I would never accuse you of cheating because that could have happened by chance. I would have rejected that the coin was fair, or I might not have rejected that the coin was fair. But I never accepted that the coin was not fair. So that's a little subtlety, basically because we might be wrong, okay? Now, how do you decide to reject or to not reject? Okay, here's how you decide. This is a very politically incorrect phrase, but it will help you to remember, okay? If the p-value is low, reject the null, or some people like to say hope, because it rhymes better, okay? Now, when we're talking about the p-value is low, what are we comparing our p-value to? We compare it to alpha. Compare to alpha. Okay? So if the p-value is low, reject the null. Okay? That makes sense? And then step number 7 is what? Write the conclusion in English, not statistician. Statistician. Okay? Which means for your conclusion, do not use the following words. Okay? Null, reject, or hypothesis. Okay? Or accept. Here, I'll put that one in there too. Just throw it in there. You should never use that one anyway, but okay? And the idea here is answer the question in English, in understandable English. Okay? All right. Somebody just sleep? Oh, it's heavy. Okay. All right. So, now just because I want to make sure you guys are on your toes, I want to do, oh, I forgot. You guys can't see, and I wrote off the board. There's the board now. Now you can see what I wrote. Okay? All right. So just for fun, and just to show that we don't always use certain letters here, I want to throw one more example at you, and then we're going to do I can't find it. I think I remember it anyway. Maybe it's here. Oh, here it is. I found it. Okay. Here we go. We're going to do an example here. Okay. All right. Example. A 64-ounce bottle of detergent is known to have standard deviation of 0.23 ounces. Company purchases a new machine and wants to know if there is less variability. Okay? So what I'd like to do is we'll go through the first 3 steps. There's not enough information to actually solve this, but I want to make sure that we can do the first 3 steps. Okay? All right, list all the important numbers. What are the important numbers?
Standard deviation.
Standard deviation. What letter do I use for standard deviation?
Sigma.
Is it sigma?
Yes.
What is it? Who agrees with Dylan? Who disagrees with Dylan? What do you think it is?
With the circle with the tail.
That's sigma. Circle with the tail. This is also sigma. That's what you were talking about, right, Dylan?
Yeah.
Those are the same letter. You need to learn your Greek. No, just kidding. Okay, this is lowercase sigma, that's uppercase sigma. Okay? So you didn't really disagree, you agreed with it. Okay? So 2 people agreed, 3 people didn't know, 3 people who didn't know, we got it wrong, but that was correct. Okay? So standard deviation of 0.23, comfort versus new machine wants to know if there's less variability. There's not a lot of other numbers there. What's the other number I should probably list here?
64 ounces.
64 ounces, is that useful to the problem? It's kind of background information. I just want to make sure I'm not using a different size bottle. Okay? Is there another number?
Your alpha.
What's your alpha?
0.05.
Alpha is 0.05 because it's not good. Okay? We assume alpha is 0.05 if it's not good. Okay? So we've listed all the important numbers. Is this data quantitative or categorical? Should we vote? Okay. Who says it's quantitative? 1, 2, 3, 4. Who says it's categorical? Nobody? Who doesn't know? Annie, you didn't vote.
It's quantitative, I think.
You think it's quantitative, change your mind. It is quantitative. How do we know it's quantitative, Annie?
Because it's not categorical. I don't know. Well, like, cause in categorical, you say like, is it, this or this, like with words, like in the example we had on the quiz.
Right.
But this is just like,
We're measuring how much is in the bottle, right? Yeah, it's definitely quantitative, okay? All right, question number 3, what's the null and the alternative hypothesis? I haven't picked on Allie yet. What do you think?
I have no idea.
No idea? What does null hypothesis mean?
Would be mu equals 0.23.
Mu equals 0.23. So Allie phoned her friend Dylan. Do you agree with that? Allie?
She does.
She does. I wish she had disagreed. But Dylan, look closer there. Do we have a mu in any of our known numbers?
No, but I just said that because it's quantitative data.
Okay. Kara, you look like you wanted to say something. Is it the sigma?
Equals.
It is the sigma, okay? We're trying to compare variation, right? So in this case, it's neither P nor mu, it is sigma, okay? It's sigma because it's about the population. Okay, we can actually do a hypothesis test on standard deviation, although you guys aren't going to learn it. But I would like you to make sure that when you're doing this, you get the letter right, okay?
What if like standard deviation and mu are given?
What if the standard deviation and the mu was given to be 64 ounces? I guess you could maybe say that 64 ounces was the mu on that, okay? But what are we trying to prove?
Standard deviation.
We're still trying to talk about standard deviation, so that wouldn't matter in this case. Okay? All right, so the alternative hypothesis order would be,
I have no idea.
oh,
Maybe let's watch
did you watch the video Monday? You should have an idea then. What does alternative hypothesis mean? Did you write down in your notes? Because we're going to pick on Cassidy if we can.
I don't.
You didn't write it down in your notes? Cassidy, what do you got? What does alternative hypothesis mean?
What does it mean? Yeah, it's a statement that we're trying to prove.
So what's the statement, Porter, that we are trying to prove?
Whether 64 ounce detergent is known to have a standard deviation of 0.23.
Well, that's the null
No, last
hypothesis.
variable.
What is the company trying to prove?
No, and what the variability is in the bottle.
There's less variability, okay? So it's supposed to be 0.23 because that's what the old machine did, right? We're calling the old machine the population, okay? So the alternative hypothesis would be,
0.23 again.
what would be 0.23?
Mu.
Why mu? Mu deals with means. What are we talking about? Signal. Whatever you stick here, you got to stick with it again. And that's your key word.
So it's gonna not equal.
Not equal to? There's your hint. Can you read that word?
So less.
List that. Okay. So is this a one or a two-tailed test when we get to step 5, which we can't get that far because we're not going to learn this test. But if we did, would this be a one or a two-tailed test? One-tailed, and it would be left-tailed. Okay? Does that make sense? All right. So you ready to do a real problem now?
That wasn't real.
That was, yeah, we could do all 7 steps. A real problem, you can do all 7 steps. Okay?
Let's do it.
All right, let's do it. Okay, this is the homework problem. This is like a homework problem that Abby asked us at the beginning of class. So here we go. Let's do another one. Example. Residents think people are speeding in a school zone with speed limit of 25 miles per hour. They learn from police that standard deviation is 7 miles per hour. They check 16 cars and find the mean speed is 29 miles per hour. Are they correct? Okay. All right, so here's what I'm going to do. I'm going to actually go through all of these questions here. And so step number 1 is what?
List all important numbers.
List all the important numbers. So those of you at home, hopefully, well, I'll list them over here. Okay. Step number 1 is what? What's the first number that we should come up with? Let's just go through it. Residents think people are speeding in a school zone with a speed limit of 25 miles per hour. That sounds important.
That's mu population.
So you think if mu is 25, that's what people are supposed to be doing. And if residents think people are going faster than that. Okay? Alright, they learned from the police that the standard deviation is 7 miles per hour. Cassidy, what's 7 miles per hour?
Standard deviation.
And what letter do I use for the standard deviation? Sigma. Okay. They checked 16 cars. Allie, what's 16?
So,
Sample size, and what letter do I use for sample size? N. And find the mean speed is 29 miles per hour. Kara, what's 29 miles per hour? With X bar, very good. Why X bar and not mu? Because it's the sample of the 16 cars, right? Are they correct? Are there any other numbers that I should come up with? Abby?
Nope.
Yep, there's one more. Dylan knows.
Alpha.
Alpha, what's your alpha?
Good. Look at Allie over here.
Okay? Why alpha equals 0.05? Because I didn't tell you what it was. Okay? Now, let's talk about my n. Is my n big enough?
Is what?
Is my n big enough?
No.
No, how big should it be?
30.
30. So I'm breaking a rule here by having too small of a thing here, but maybe.
Wait, the reason it's 30 is because of what? Again, can you repeat that please real quick?
Why should it be 30?
Dealing with means.
What?
Because we're dealing with means.
We're dealing with means, and what says it should be 30 or bigger?
Central limits.
Central limit theorem. Okay, so this is actually too small. Now, you can get away with smaller sample size. Let's say that we did a histogram and it looked pretty normal, we could probably get away with it. Okay? But we are breaking a rule here with rule number 1. Okay, it's too small. Okay? All right. Step number 2, I'm going to turn my camera over here, is, what's step number 2? Is the data categorical or quantitative? Should vote. Who says it's categorical? Nobody? Who says it's quantitative? Okay, it's unanimous. It's quantitative, definitely quantitative. Okay, now by the way, I'll save that for later. Okay? Well, no, I'll answer that now. All of your questions in chapter 17 are quantitative. Okay? But don't get pigeonholed because we're going to follow these steps. Find the null and the alternative hypothesis. Who needs to practice on this? Cassidy looks like she needs to practice on this. Okay, what's the null hypothesis?
Is it equals 29?
Equals 29.
I don't know, I'm kind of guessing.
Okay, she didn't pick a letter, so even if this is correct, it's only half correct. Who agrees that something equals 29 is correct? 1, 2, who disagrees? Abby, what do you think it should be?
I think it should be U equals 25, and then mu.
So you change it to 25?
I don't think so. But that's
Mu
just-
equals 25. Why did you say mu equals 25?
Because it's given,
The 29 is given too, right?
But that's a sample.
29 is the sample. 25 is the population. At least that's what the population's supposed to be doing, right? They may not be doing that, but that's what they're supposed to do. Because remember, the null is always about the population, and 25 is the population, 29 is the sample, okay? So mu equals 25 is correct. Annie,
Yeah.
what's the alternative hypothesis?
I was thinking it was greater than 25, but I already thought the answer, so I don't know.
Mu is greater than 25. Why did you say greater than 25?
Because they think that everyone's speeding.
Because they think everybody is speeding. Okay? So is this going to be a one-tailed or a two-tailed test? It's gonna be a one-tailed test, it's gonna be a right-tailed test, correct? Okay? All right, so now, at this point, we need to pick the correct test, okay? We said it's quantitative, so rather than 4 choices, I'm down to 2. The question is it a one sample mean with a sigma known, or is it a one sample mean sigma unknown? Sigma is known, right? Okay? All of your homework in chapter 17 is going to deal with that equation. But basically, we're going to pick different chapters and we're going to come up with different equations. And I might add another test to this. I probably will. But these are the 4 for sure I'm going to cover. Maybe a 5th. Probably a 5th. Okay? So now that we've got z equals here, we can just plug in all those numbers that we picked out before. So Porter, since we listed all those numbers in step number 1, can you help me do this z equation here?
Sure. So we have z equals 29.
29
minus
25
all over, so we have sigma, which is equal to 7.
7
all over
square root of,
I don't know what n is though.
n's over here. What's my n?
16.
And 16 right there, okay? All right. So now, see, wasn't that nice to write all that stuff down in step number 1? Okay, now who can punch that through? Here, I'll show you how to.
2.28571.
That sounds like the correct answer. 2.28571. Okay.
Look at us.
Look at that. We're cooking with gas like that. Okay, so we can skip all this. Now, step number 5. Oops, passed it. Step number 5 says, find the p-value. There's 2 methods you should be able to do it in the chart or Excel. And is it a 2-tailed test?
No.
No, it's a 1-tailed test. And which tail is it?
Right.
Okay. We think they're going 25, or the null hypothesis says they're going 25. We think they're going faster, 29. The question is, what is that area? Okay. We've just converted it to a standard normal curve so that this mean is now 0, and this number is now 2.28, right? Okay. So how do I use the chart to find this?
You go find the value of your z-score.
Find the value of your z-score on the chart. Hopefully, let's see if I can do that here quickly. Okay. Here we go. Equals 29 minus 25 equals 7 divided by the square root of 16 equals that divided by that. Okay, that's your z-score. Okay, we're going to look up our chart. File open. Hopefully.
0.987.
Here it is. So we're looking at 2.28 on the normal distribution. Positive 2.28. And as, is that what you said?
You're at 2.18. So if you go down 1, it's 0.9887.
There we go. I was on the wrong line. 2.9887. So is that the correct answer? Is this area 0.9887?
No.
No. What is that? Well, that's the white area, right? Okay. So this is 0.9887. This area here is
1 minus.
1 minus that. 1 minus 0.9887. Okay, so let me add another thing on here. Draw. Actually, let me back up. Instead of answering it that way, what would Rick do?
Draw a picture.
Rick would draw the picture so that he doesn't mess up his p-value. 1 minus 0.9887 equals 0.0113. Correct? Okay? So that's the answer we get with the chart, 0.0113. What do we get with Excel? How do we do that? Because a lot of you use the chart and you lost your point.
Did you ever give him a point
I
back?
don't think I did. But I will. Okay, what's the command that you're going to use? Norm as dist of that number there, which is going to give you 0.9888. Actually, it's a little different. Okay, and we're going to go 1 minus that number. So 0.0111. So with the Excel, we're going to get a slightly different number, right? 35. Okay. So this is the correct answer on the quiz on Friday. This will be the correct answer on the test in a couple of weeks. Okay, slightly different. Which one's more accurate? Excel is. Okay. Do I need to double it? No. Don't need to double it. Why would I need to double it if I do?
You have both sides.
Because I would have had a 2-trailed test. Okay. All right. So we're almost done. Step number 6. I need to decide whether to reject or to not reject. How do I decide that? Do I reject?
Yes. Wait. Yes.
So we vote. Who says reject? Who says do not reject? Okay, reject is the correct answer. Reject because my alpha, 0.0113, excuse me, my p-value is less than my alpha. Okay, so reject the null. We no longer believe, so the null says people are driving the speed limit. We don't believe that. What do we believe? What's our conclusion in English?
We believe people are not speeding.
There is evidence that, say it again, Abby,
That people are not speeding.
people are not speeding?
No, people are speeding.
Are you sure?
No, what do you make me all confused there?
I would say they're not speeding.
They're not speeding.
The school zone.
Okay, so let's go back here. This is the confusing part. Here's what's really frustrating to me. When people get the first 6 steps right and then trip at the finish line. Okay? Let's go back to the null here. Okay? The null says people are not speeding, right? They're driving 25 miles an hour. We have rejected the null. We think people are speeding. Okay? Yeah, you said both.
Well, you told me I was wrong the first time.
No, I didn't. I said, are you sure?
Oh,
You weren't sure.
I was.
Okay? There is evidence that
people are speeding.
people are speeding. Now the question is, will they get a ticket? Did you get a ticket for 29 and 25?
Yes.
Depends on the cop.
Depends on the cop.
Yeah. I did this.
Okay?
Really?
All right. So, quiz on Friday. I think this, actually, let me just mention this really quickly, because I think I didn't give you enough of these hypothesis tests. I might give you some extra homework so that you can ace this and also ace your project. If you haven't started collecting data, don't wait until the last minute, okay? Because not only do you need to collect the data, but you gotta go through these 7 steps, and you need to make sure that you can do a confidence interval, okay? Which we learned clear back on the last test. We're gonna learn confidence intervals. These 7 steps not only help you pick the correct hypothesis test, but the confidence intervals follow all of the same rules, okay? So that will help you with confidence intervals as well.
So would you say quiz on Fridays like this?
Quiz on Friday, going through all the 7 steps, make sure you know them.
Oh, gee.
Oh geez, yes, know them all. And you can do a problem like this. What if I gave you raw data, like the actual speed of the cars? Could you find the mean yourself?
Probably not.
Yeah, I'd have to still give you this, but you could probably find the standard deviation if I give you it to you in Excel, right? Okay? All right, so see you all on Friday.